Section 4.5, Exponential and Logarithmic Equations, Part 3. Okay, so solving exponential equations, we have two methods that we've been practicing. If we can write the bases equally, that's going to be the easiest way to solve. Once we write the bases equally, we just set the exponents equal to one another. But we're not always able to get the bases written equally. When we cannot do that, then we use our other method, which is to isolate the exponential expression, take the log of each side. Remember, we're taking the log of each side because a logarithm is what undoes an exponential. Then we're ready to solve for our variable, and we can check our answer. You can always check an answer whenever you're working with an equation. Okay, so let's look at problem number 38. We'll take this and multiply it over to the right-hand side of the equal sign. So that gives us 10 is equal to 2 times 1 plus e to the negative x. Okay, next we're going to divide both sides by 2. If I divide both sides by 2, we end up with 5 is equal to 1 plus e to the negative x. Next, we're going to subtract 1. Remember, we're isolating the exponential function. That's the step that we're on. So we'll subtract 1 from both sides. That gives us 4 is equal to e to the negative x. Now we can take the log of each side. We have isolated our exponential expression. So that gives us the ln of 4 is equal to the ln of e to the negative x. Now, before in the equations that we looked at, we can use ln for base e. We can use log for base 10. Here, I want to be able to use the ln base e because it's going to cancel e. We learned that because they're of the same base, they cancel one another out. So we end up with the ln of 4 is equal to negative x. And finally, dividing over that negative, we get negative ln of 4. This is the exact answer. If I want a decimal approximation, all I have to do is put in ln of 4 into our calculator. And when we do that, we get 1.386. 294. Exact answers are what we always give, but if we want an idea of what this exact answer equals, there's where we do our decimal approximation. Okay, let's look at our next example. These are quadratic in type. Let's see how this could be quadratic in type. Well, what we could do is we could let m equal e to the x. If I square both sides, we get m squared is equal to e to the x times e to the x. And if I have the same base, we add the exponents together. Just like same base, x squared times x to the 5th, that gives us x to the 7th. Because it's the same base x, we add the exponents and get 7. Because these are the same base, base e, we add the exponents and get 2x. So if e to the 2x is equal to m squared, e is equal to m. Notice that we have an equation that is quadratic in type, and that's where they're getting that part of the problem. Okay, so here we then, to solve a quadratic factor or the quadratic formula, so that would be m minus 3, m plus 2. We set each factor equal to 0. Here we're going to get m is equal to 3. Here we're going to get m is equal to a negative 2. But what were we solving for? We wanted to know what value of x made this equation true, not m. So we have to go back and undo m and go back to e. Not as hard as it sounds. What we said here was m was equal to e to the x power. So we'll just say 3. That's what we got for our first m. 3 is equal to e to the x. What's happening with the pen? Let's try one more time. 3 is equal to e to the x. And also negative 2 was equal to e to the x. Negative 2 is equal to e to the x. Okay, and then we just solve for x. How do we get rid of e? If I need to get x, I need to get rid of base e. What gets rid of an exponential? A logarithm. What gets rid of e? ln. So we have the ln of 3 is equal to the ln of e to the x, which is just x. So x is the ln of 3. Oh, sorry this is going so slow, but I'm not sure what's happening with this pen. Okay, we're going to do the same thing for the opposite side. We're going to say ln, we're going to ln both sides. We're trying to get rid of this e in e to the x, even though it doesn't look like an e. There we go. Okay, so we've got ln both sides to get rid of that e. So we have the ln of negative 2 is equal to the ln of e. Okay, ln of e cancel out. But before I box this answer, try putting negative 2 into your calculator and natural logging it. You're going to get an error. Remember the log graphs? What was the domain of the logarithm? The domain for a logarithm was a positive number. We're not able to ln a negative number. This is our only answer. Okay, that is the end of part 3.